Hello everyone, welcome to my channel, and today we'll be talking about Agentic RAG. So it is when your AI decides how to search. So watch this. I'm going to ask the same question to two RAG systems, compare refund policies from 2023 and 2024 and tell me what changed. So in the left side, the traditional RAG searches once, grabs whatever chunk seems relevant and gives me a vague answer with mixes up the year. It doesn't know it needs to search twice, once for 2023 and once for 2024, and then compare. So now watch the agentic RAG. It reads the question, realizes it needs to separate searches. It searches for 2023 policy, then 2024 policy. It checks if it is found enough information. It notices if anything is missing, then returns the window details. So it searches again with a more specific query. Okay, then it compares them and gives a detailed, accurate answer with citations. So that's the difference between the traditional RAG that retrieves and agentic RAG that thinks, then retrieves, then checks, then retrieves again if needed. So it is a RAG with a brain. This is the part of my RAG series. If you haven't seen the earlier videos on RAG basics, chunking and advanced retrieval, links are in the description. So today we will be going to the frontier. So let's go. So what is agentic RAG? So let me make this crystal clear. So traditional RAG is a straight line. So user asks question, system retrieves the chunks, LLM generates the answer. One shot, no thinking, no looping, no decisions. In agentic RAG, puts an AI agent in the driver's seat. So the agent can plan what to do, decide whether to search or not, choose which tool or database to use, evaluate whether it found enough information or not, and then loop back if it needs more. So think of traditional RAG as a vending machine. You press a button, you get what you get. Okay, the agentic RAG is like research assistant. You give them a question, they plan their approach, check the multiple sources, verify their findings, and come back with a thorough answer. So agentic RAG has typically four patterns. As you can see in this slide, it is built upon four core patterns that, so remember this because everything else that we talked today about builds on them. So first pattern is planning. So the agent breaks a complex question into steps, like compare 2023 and 2024 policies becomes the step one. Find 2023 policy is the step two, find 2024 policy is the step three, and then compare. So the second pattern that comes in is the tool use. So the agent can use different tools. Maybe it searches a vector database for one thing, it's an API for another, queries a SQL database for a structured data, and searches the web for the latest news. So it picks the right tool for each subtask. Third pattern is reflection. So after getting this result, the agent checks itself. Did I find enough? Is this actually answering the question? Are the gaps too big? If the answer is no, it goes back and tries again. This is CRAG, corrective RAG, which I mentioned in my advanced RAG video. The link is in the description. So the pattern 4 is multi-agent collaboration. For really complex tasks, okay, you don't use one agent, you use multiple agents working together. One searches the document, another searches a query database, a third verifies the facts, and a supervisor coordinates them all. So let me tell you out of these patterns what the agent actually does, why it matters, and the real world analogy to make you understand and remember. So the first pattern is planning. So it breaks down the complex question into steps. It is generally used, it is matters because multi-hop questions and where there is need of multiple searches. In those cases, it is used. So it is basically a detective creating an investigation plan, for example. The tool uses like for it picks the right tool or database for each step because different data lives in different systems. So it is like a chef choosing the right knife to each ingredient. Okay. Next is the reflection pattern. So it checks if the results are sufficient and it retrieves if it is not sufficient. Okay, so it catches the gaps and self-corrects before answering. So it is like a student rereading their essay before submitting. So the last one is the multi-agent. Okay, so the multiple specialized agents work in parallel. It is generally, it matters in the complex tasks that need parallel processing. So a team of researchers, each covering one topic, can be a real world analogy for that. Now let's go to the next slide, that is the ReAct pattern. So this is how agent thinks. So the foundation of most agentic systems is a pattern called ReAct. It stands for reasoning plus acting. Okay, and it's beautifully simple. So the agent follows a loop. Step one, that is think. So the agent thinks for the reason. So basically the agent reasons about what it needs to do in the next step. Okay. Then the step two is act. It takes an action like calling a search tool or a database. And the step three is observe. So it looks at the result, then it goes back to think and decides what to do next. So this loop repeats until the agent decides it has enough to answer. So let me walk you through a real example. You'll understand it better. So a user asks, what is the total revenue from Q3 2024 and which product line contributed the most? So in the think stage, I need Q3 revenue data. It will think, okay, I should search the financial reports database. So now it will act. So it searches the vector DB for Q3 2024 revenue total, and then it observes, okay, the found a chunk that says the total revenue was 4.2 million, for example, but it doesn't mention the product line. So it will think again, okay, in the loop. I have the total, but I am missing the product line breakdown. So I need to search the again. Then it will act and search for the Q3 2024 revenue by product line, and it will observe and it will find the table showing the enterprise contributed 2.8 million and SMB contributed 1.4 million. Okay, then it will think again. I now have both the pieces. I can answer this question. So the answer will come as Q3 2024. Total revenue was 4.2 million. Enterprise was the top contributors at 2.8 million, followed by the SMB at 1.4 million. A traditional RAG system would have searched once and probably given you an incomplete answer. So the ReAct agent searched twice and got it right. Yeah. So next thing is agentic RAG architecture. So let's build this layer by layer. Okay, the simplest agentic RAG uses a single agent with an access to tools. So the agent has a system prompt that defines its role and capabilities. It has access to the tools, a vector search tool, maybe a web search tool, maybe a calculator, and it has a state that tracks the conversation history and what it's found so far. Okay, when a question comes in, the agent decides, do I need to search? Which tool do I need to use? It searches, evaluates, and either answer or search again. This is what LangGraph or LlamaIndex agents give you out of the box. So next, coming to the router pattern that you can see in the slide, which is one level up, is the router pattern. So before doing any retrieval, an intent classifier looks at the question and routes it to the right pipeline. Simple factual questions route to the basic RAG. It is fast and cheap. Complex multi-hop questions, it will route to the agentic pipeline with the ReAct. So if you need structured data, route to the SQL agent. Need real-time info, route to the web search agent. As simple as that. This is how production systems handle cost and latency. Not every question needs a full agentic loop. A simple what's our office address should not trigger 5 rounds of retrieval and reflection. Okay. So the router ensures you use the right level of complexity for each query. Next comes the multi-agent architecture. For most complex tasks, you use multi-agent. Okay, here's the typical setup. A supervisor agent receives the question and creates a plan. It delegates subtasks to the specialized agents. A document agent searches your internal knowledge base. A data agent queries your SQL database. A web agent searches the internet for the latest information. Okay, a verification agent checks the combined result for the consistency and hallucination. So each agent works on its piece, sends results back to the supervisor, and the supervisor synthesizes the final answer. So the agent can even work in parallel. Okay, the document agent and the data agent don't need to wait for each other. So this is where like Microsoft's AutoGen, CrewAI, and LangGraph all support this pattern. Okay, the LinkedIn's Graph RAG uses a multi-agent setup and reduce their support resolution time by almost 30%. Yeah. Next comes the evidence gap analysis pattern. So this is my favorite pattern and the one that really shows what agentic RAG can do. After retrieval, instead of just sending the chunks to the LLMs, the agent runs an evidence gap analysis. So it asks, does the retrieved context contain enough information to fully answer the question? Are there specific sub-questions that aren't covered here? What is missing? If the gaps are found, then the agent generates the new, more specific queries targeting exactly what's missing, retrieves again and fills the gap. It keeps looping until the evidence is sufficient or it has hits the maximum retry limit. So this is what makes the agentic RAG dramatically better on the complex questions. Okay, a research implementation showed that the significant improvement in context precision and recall on multi-hop queries compared to the single shot retrieval. If you want to know about this context precision and recall, I have made the video about advanced RAG that is in production. Okay, you can go through that. The link is in the description also. Next comes the framework and tools. So let's talk about what you actually use to build this. Okay, if we are using LangGraph, it is best for the custom agent workflows and production RAGs. The main features, key features are like graph-based orchestration is there, state management is there, human in loop also it supports, even checkpoints, etc. But we need to watch out because it has a steeper learning curve than a plain LangChain. Next comes LlamaIndex agents. Okay, it is RAG first agentic system. Okay, built-in RAG tools, query planning, sub-questions, engine, data connectors, etc. it supports, but it is less flexible for a non-RAG agent task. Next comes Microsoft's AutoGen. Okay, it is a multi-agent conversations it supports. And the main features are like agent-to-agent messaging, code execution, group chat patterns. These all things are supported, but it can be a bit verbose. Okay, designed for like multi-agent first, that's why. Next comes CrewAI. Okay, so it is a role-based multi-agent teams. Okay, so agents with the roles, goals, backstories, task designation, delegation, etc. So easy to conceptualize also. Okay, but the abstraction can limit the fine control. That's the only problem. And in AWS Bedrock, it is an enterprise managed agent. Okay, built in the knowledge bases, action groups, sessions, managements, no infra to manage at all. Okay, everything is handled in the AWS itself. But the only problem is it is only AWS and less customizable. In case of Azure AI agent service, it is a Azure enterprise ecosystem. Okay, so in this agentic retrieval with Azure AI, like search function calling, grounding, etc. it supports, but it is only Azure only service and it is a little bit newer service. So here's my honest recommendation. If you are building a custom agentic RAG pipeline and want full control, use LangGraph. It gives you graph-based workflow orchestration where you define exactly how your agent moves between the states. It's what production teams are using in 2026. If your use case is purely RAG focused, like searching the documents, querying the data, answering the questions, okay. So for those LlamaIndex agents are the simpler to set up because they come with the RAG specific tools built in. And if for multi-agent setups where you want specialized agents working together, the CrewAI is the best and easiest to get started with. AutoGen is a little bit more powerful, but yeah, more complex also. And if you are in an enterprise that runs on AWS or Azure, their managed agent service handles a lot of infrastructure for you. There's less flexibility, but way less ops work also. So let's go to the next slide, that is our real world use cases. Yeah. So let's pick up the use case one, that is enterprise knowledge assistant. So an employee asks, what's our parental leave policy for London employees hired after 2023? So this question needs three things: the right policy version, the right location, and the right date filter. An agentic system plans this out. First, identify the correct policy version by filtering for the UK policies. Second is the retrieve the parental leave section. Then third would be check if there's a higher date clause. If ambiguity remains, so the agent asks follow-up questions or escalate to HR. Traditional RAG would just search the parental leave and pray. Next use case that we should move on to is financial analysis. Okay, so financial analyst asks, compare our Q3 expenses to the budget and flag any department that's over 110%. So this requires searching unstructured financial reports and querying a structured SQL database for the budget numbers. So the agency system routes this to two agents. A document agent searches the financial reports for Q3 expense breakdown. A data agent queries the budget database for planned amount. So the supervisor merges the data, calculates the percentage and flags the department over 110%. So the next use case that we are going through is customer support copilot. So a support agent asks the customers, says their invoice shows the wrong amount. How do I fix it? So the agency system searches the knowledge base for the invoice correction process, checks the customer's account in the CRM, retrieves the relevant invoice from the billing system, and provides the step-by-step instructions specific to that customer situation. Even DoorDash built exactly this. Okay, so for their Dasher support. So multiple specialized agents handling different data sources coordinated by central planner. So the next use case is legal and compliance. Okay. A compliance officer asks, do our current data handling practices comply with the EU AI Act requirements effective August 2026, for example? So this needs multi-step retrieval across internal policy documents, the actual regulation text, the recent guidance updates. Okay, so the agent searches internal data, handling the docs, retrieves the relevant EU AI Act clauses, checks for the recent amendments or guidance, and produces a gap analysis with citations. So a verification agent then checks for the contradiction or missing citations before the final answer. So this is a high stake, so you can't afford hallucination in the compliance. Next comes up when not to use the agentic RAG, when you can skip it. So this is the section nobody makes, but everyone needs. So agentic RAG is powerful, but it's not always the right answer. Don't use it if for simple factual lookups like what's our address. Doesn't need any agent planning and reflection. So basic RAG with good chunking handles this faster and cheaper. So don't use it when the latency is critical. Each agent loop adds time. A single ReAct loop might take around 3 to 10 seconds. If your user expects sub-second response, agentic RAG will frustrate them. Next is don't use it when you can't afford non-determinism. So agent makes decisions and those decisions can vary between the runs. For highly regulated environment where you need identical outputs for the same input, a fixed pipeline might be safer. And also don't use when you haven't built the basic RAG well first. If your chunking is bad, your retrieval is noisy, and your evaluation is non-existent, adding an agent layer won't fix those problems, it will amplify it. So to sum it up, you have to use agentic AI when there is complex multi-hop questions that needs multiple searches, not for the simple factual lookups with one clear answer. Okay. You can use it when the question spanning multiple data sources like doc, web, DB, etc. For a single source, well-chunked documents, we don't need agentic RAG. And we can use for the tasks like that benefits from the self-verification and gap filling, not for the latency critical applications that are sub-second requirement. Okay, and other is like agentic RAG can be used when there is dynamic routing is needed based on the question complexity. Okay, and should be as the agent cost is more, so if there is a budget constraint for prototypes, you don't need to use that. It is mostly better to use agentic when it is a high stake answers like legal, medical, or compliance. Okay, so basic RAG isn't working well for those. So we have to use this agentic RAG. So smart way to handle this is a router pattern that I mentioned earlier. So let the simple questions go through the basic RAG, route the complex question to the agentic pipeline. So best of both worlds. So next comes the challenges and mitigation. So agentic RAG is powerful, but it comes with a real challenges. So let me be honest about them. So the challenge one is infinite loop. If your reflection logic isn't well designed, the agent can get stuck in a loop. It searches, decides it's not enough, searches again with the same query, gets the same result, decides it's not enough forever, and it continues forever. Always set a maximum retry limit. 3 to 5 iterations is good default. Challenge 2 is the compounding hallucination. Here's a scary one. The agent retrieves some context, generates a partial answer, then uses that partial answer to form its next search query. Okay, if the partial answer has hallucination, then the next search is based on the false information, which leads to more false results, so the error compounds. So this is why verification agent pattern is critical in production systems. Challenge number 3 is the cost explosion. Each loop costs money, multiple LLM calls for planning, tool use reflection. So multiple retrieval calls, if you are not careful, a single complex question can cost around 10 to 50 times more than a basic RAG query. So monitor your cost per query and set a budget. Another challenge is observability. Okay. So when something goes wrong in a multi-step agent, debugging is very hard. You need to log every step, what the agent thought, what it decided, what it searched, what it found, why it is looped. Okay, so Langsmith and my first video on observability are your friends here. So moving on to next challenge, that is latency. So real users don't wait for 15 seconds for an answer. So we need to stream the intermediate result, like show the user what agent is doing while it works. Searching financial report, finding Q3 data, checking budget database. So this turns waiting time into engagement. So let's move on to the next slide, that is building your first agentic RAG, a clear roadmap. So all right, you want to build this, here's the practical roadmap. Step 1, make sure that your basic RAG works well. Good chunking, hybrid search, re-ranking, metadata. If you have followed this series, you already know how to do this. Step 2, add a simple router. Okay, so classify the incoming queries as a simple or complex. So route the simple ones to the existing pipeline, route the complex one to the agent. Now step 3, build a single ReAct agent, give it access to the search tools and a done action. Okay, so let it decide when to search and when to answer. Start with the LangGraph or LlamaIndex agents. Step 4 is add the reflection. So after retrieval, have the agent check, is this enough to answer fully? If not, let it search again with a refined query. Set a max of 3 retries. Step 5, add a multiple tools if needed. Maybe you need to SQL access or web search or an API. So add tools one at a time and then test each edition. Now step 6, If you need it, move to the multi-agent. Only when a single agent can't handle the complexity alone. Okay, or else don't. Don't start here. Most use cases don't need it. Next comes the step 7, which is evaluate obsessively. Okay, use ragas, log every agent steps, monitor cost per query. Okay, so A/B test agentic versus non-agentic on the same question. So the most important thing to remember is 57% of the organization now have agents in the production, but the quality is still the number one blocker. Don't rush to complex architecture, build a solid fundamentals, then add an intelligence layer. Okay, so moving on to the next slide, that is pipeline RAG versus agentic RAG versus graph RAG. So before we wrap up, let me put all three major RAG architectures side by side so you know which one fits your use case. So in pipeline RAG, it retrieves once and generates. In case of agentic RAG, it plans, retrieves, evaluates, and loops. In graph RAG, it traverses the knowledge graph relationships. So in the pipeline RAG, it is for simpler Q&A, FAQ, single hop one. Agentic RAG can be used for multi-hop, complex, multi-sources also. And graph RAG is used for relationship queries, entities connections are there. Okay, like for example, AI Abhi is working in this particular company in this role, so they have relationship between them. So that is best for those. Speed wise, pipeline RAG is the fastest. Okay, as it has a single retrieval. Next comes this agentic RAG, which has multiple loops. And in the final is the graph RAG. It is moderate. Okay, so graph RAG, it has graph traversal, that's why, compared to others. In cost wise, pipeline RAG is the lowest costing. Okay, agentic RAG is medium to high, and graph RAG has high costing, as graph construction, etc. is there. For that, we can maybe use knowledge base like Neo4j, etc. Accuracy wise, the pipeline RAG is good for simple queries. Agentic RAG is good for excellent for this complex queries, and graph RAG is for relational queries. Complexity wise, graph RAG is the most complex, followed by agentic RAG, followed by the pipeline RAG. So example could be like for pipeline RAG, it can be what's the return policy. Okay, these type of things it can answer. In agentic RAG, it can answer like compare Q3 versus Q4 across departments. And graph RAG would be like how is product X connected to the customer Y. So most teams in 2026 start with the pipeline RAG, add a router, and the query complexity varies. Introduce the agentic pattern for complex workflows, and only go to graph RAG when it's needed. The relationship aware reasoning. Thus the maturity curve. So moving on to the next slide. So let's wrap up with the key takeaways. Okay, that is agentic RAG puts an AI agent in control of the retrieval process instead of searching once and hopping for the best. So it plans, retrieves, reflects, and iterates until the answer is solid. There are 4 core patterns that are planning, tool use, reflection, and multi-agent collaboration. Master this and you can build anything. Next comes, we use ReAct as a base pattern, so adding the routing to manage cost, and adding reflection for quality, and adding the multi-agent when you only need it, or else don't. But don't forget, 57% of the organization have agents in production, but the quality is still the biggest blocker. Okay, build the strong fundamental first, measure everything, upgrade layer by layer. So this has been the part of my RAG series. Okay, we have gone from what is RAG all the way to AI agents that plan their own research. If you want me to build this entire AGT system from scratch in the next video, code, tools, everything, smash a like button and tell me in the comments. Subscribe if you haven't. I'll see you in the next one.